All right. So what I was going to have you guys do again was compare these box plots on the left. I'm trying to make it so you can see all of it, that's about the best I'm going to be able to do. Compare the box plots right here to these histograms on the right. Now the dot plots are exactly the same as the histograms, so that's not a challenging thing. And the two that I think most people are going to be just fine with, box plot number 3, which one do you think that connects to over here?
Histogram number 4.
There it is, histogram number 4. Very good. You can see it definitely has a right skew, and you can see the right skew going on there. This one right here, it's a little bit trickier, but which one do you think that goes to?
2.
2. So this one, you can see there, it's a weird distribution. There's maybe something of a left skew, and that's what you can see here. Not as strong of a skew, but there's something going on. Okay, the next 3, 1, 2, and 5, just to talk about these real quick, you can see that in number 1, all the quadrants, all the quartiles are the same width, which means we're going to have the same amount of data in all 4 of these, which means that that is a uniform distribution. How that changes is if some of the data gets more concentrated in the middle or on the edges, that'll change the shape of the histogram. So number 2 is a weird one because the middle 50% of the data is really wide, which means there's a lot of data in the outer quartiles. And that means that's going to match up with number 1. And kind of the most standard looking box plot that you see is this one right here, where the interquartile range is actually small. The whiskers are longer, and you have what looks to be like a regular distribution that you're familiar with. Okay, so that I wanted to run through. I think we're good to go now. What we are going to do today is look at some multiple choice questions and some FRQs. Try and do this as fast as I can while still giving you all the information you need. It is going to be a lot of me talking today. And the reason for that is that I can go through just some generic ideas about stats and overviews, but there's a lot of little nuance here and there. And I figured the best way to go over that is for me to just pull up some questions where that nuance comes into play. So hopefully you guys stick with me the whole time and you're following along, but I'm going to try and get through these multiple choice questions. The one thing I want to mention right here at the beginning is you have a homework assignment tonight, which is it's 2 FRQs. And I put it very clearly in the Canvas that one of those FRQs will appear on your test. So if you do your homework, let me get this up. If you do your homework this weekend and get both of those FRQs done, you already have one of your test questions answered. And if you have more questions on what the test is going to look like, just stick around later and we'll go over that. But let's get to the multiple choice questions. If you have questions along the way, you can raise your hand. I do have my participants screen pulled up so I can see anything, or you just speak up. Okay, I picked all these questions, at least I tried to, because I feel like there's something we can learn from it. And in the first question, you can see a relative frequency bar chart based on grade level. And this shows what proportion of all these different grade levels participated in school-sponsored community service activity. And the key thing with this is that you have to very seldom say anything related to the number of people participating. So if there's a question that's related to that, you can't really say much about that. So let's look at what I mean by that is if you look at the first answer choice, the greatest number of participating students was in grade 9. Well, it's the greatest proportion was in grade 9, but we don't know that it's the greatest number of students. There might only be 100 ninth graders, and there might be 800 8th graders. That's extreme, but you can see that the proportion of 9th graders might be the highest, but it might not be the biggest number represented. All right, so anything related to that? So no, we can't say that's true. Number of participating students in grade 6 was equal to the number in grade 7. It's the same relative frequency, but no, not the same number necessarily. The relative frequency of all participating students in grades 6 and 7 combined was 0.6. Well, mathematically, what happens if you have 30% of, let's say this is 20, and no, well, let's do something that works, of 21, and this is 24, and you have 30% of each, well, that's going to be, no, I shouldn't have done that. I can't do math. Let's say it's 20 and 30. Okay, if you have 30% there, that's going to be 6 students. If you have 30% of 30, that's going to be 9 students. Combined, that's going to be 15 students out of 50 total, which is still 30%. So combining those doesn't make it 0.6, it makes it 0.3 still. So it's not this one. Hopefully that you followed along with that. Grade 12 had the least relative frequency. Yes, that's true. Grade 11 had the greatest. Well, it's got a lot, but it's not the greatest. Okay, so there's that first question. Some of these we go through faster. Like this one, the only thing I wanted to point out is that when you have a frequency chart, sometimes you're going to need to do some calculations, maybe add up the total, because it doesn't tell me how many total pies there were. But if I add that up, you know, just quick guess without actually doing the math, I'd say there's 90 pies or so. Now I can get the exact number, but we might have to add that up, and then whatever that total happens to be, about 90, we could, you know, take the 14. So if we want to find the proportion that were blueberry pies, we could do 14 divided by 90. You'll have to do some calculations on this, so don't shy away from doing stuff like that. Okay, I don't need to go through that because it's really not, all in all, a terribly complicated problem compared to some others. This right here, this is something I failed to talk about because it's not in your textbook, and it is something that you need to know. It's on the, oh, it actually was 90. Wow, so it's good. Thank you. Okay, on the AP test, it's important for you to understand the difference between continuous and discrete. And we talked about categorical and quantitative, but what we have is if you have numbers, the numbers themselves could be continuous or discrete. The basic difference is something like your weight is the easiest example of a continuous variable, because you could weigh 155 pounds, you could weigh 156 pounds, or you could weigh 156.75 pounds, 156.6 pounds. You could be any of those values in between. It's continuous. But if I ask you how many books do you own? You own 12 books, hopefully more. But if you own 12 books, you can't own half of a book. So the next number you could go to is 13. It's discrete. So if you're collecting a bunch of data, you can only collect in integer values. It's not always just integers. It might be, you can measure in half of a, like 12, 12.5, 13. Those are the only values it could be, and it couldn't be anything else. So just keep in mind, discrete means that there's gaps between the possible values. Okay, knowing that this question isn't too difficult, I wasn't planning on answering it, but what is the best classification of data here? It looks like that's quantitative because they're counting its measurements and stuff like that, and discrete because you can't sell half of a video game. All right, not a complicated concept, but make sure you understand what that terminology means. Question 4, the only thing here, we don't even have to analyze this two-way table. We just need to figure out what the best display would be. And this is, you know, it's easy. You could kind of go through and maybe convince yourself of everything here, but one thing to keep in mind is that two-way tables are just for categorical data. Okay, it's only categorical. So we need to find a categorical display. Stem plots, that's quantitative data. Scatter plots, we haven't talked about it yet, but that's quantitative data. Box plots, that's quantitative data. Segmented bar charts, okay, that's categorical, that's a possibility. Dot plots, that's quantitative. So the only data display for categorical variables is the segmented bar chart. That might be where your mind went to right away, but you can use a sort of guideposts along the way. Is it categorical or quantitative? Which one even makes sense? Okay, so hopefully that was helpful. All right, next one. We have some segmented bar charts right here showing, and there's relative frequency bar charts. So we can see some questions related to this. Now, I mentioned that you have to be very careful when it talks about the number of people doing this and that. So let's look at how we can use numbers. So if we look at, D, answer choice D, it says for students in grade 7, the number who chose activity C was greater than the number who chose activity B. And that's actually the correct answer, but we can compare numbers that way within the group. We know the number has to be higher because this represents 100% of the 7th graders, if we focus on just this middle one. So if that's 100% of the 7th graders, we know that this number has to be higher than this one. What we don't know is between the bar charts. I don't know that this number right here is bigger than this number. It could not. But within the segmented bar chart, we know the numbers have to be bigger or smaller. So hopefully that distinction makes sense. Okay, and that's all I was going to say to that one. And again, remember the whole idea here is nuance. And this is a type of question, a question like this is not going to be on the test, but it's a really good question to understand. If you understand this, then you understand independence, okay? So you might not be able to answer this one right now, but when we're done, hopefully you feel like I can answer a question like this moving forward. Okay, independence means that whether you are in one category or another, it doesn't determine how you feel about the other category. So in this one, it's a survey was taken of 210 people at an ice cream store, and 70 were adults, 140 were children, 150 indicated cone as a preferred method of eating ice cream, and there was no association between age and preferred method of eating ice cream. So let's create this chart. It's important to know conceptually what's going on. I'm going to create that quite big. Here's your adults. Here's your children. I'm creating it the same way the answer choices are and the totals. We could have it in the cone. We could have it in the cup. We could have it in the totals. Sorry, and then there's the total. We know 210 people were surveyed, so we can't rule anything out just yet. We know that 70 were adults, so that's the total number of adults. It has to go in the marginal distribution. That means 140 were children. So again, all of them are set up that way. We can't rule anything out. Cones versus cups, 150 preferred cones, which means 60 preferred cups. They're making this question hard. All kind of the low-hanging fruit, they're all the same. So where it all mixes up is right here in the more difficult part of this two-way table. The fact that it's independent means that there's no distinction. And so let's kind of break this down, and hopefully it makes sense in some ways. 150 and 60. If I kind of break this down into percents, 150 out of 210, well, let's see, if I simplify that down, that's going to be 5/8 of the data, right? No. 5/7? No, I cannot do my math right now. So I'm trying to simplify. So that's going to be, 5/7. So 5/7 of the data is here. That means 2/7 is right here. Now, knowing that's true, it works out really nicely that we happen to have things that are divisible by 7. Maybe another way of thinking about this is that this value right here is 2.5 times that other value. Okay, so let's kind of think of how we could get this proportional breakdown. If there's no difference, then I need to have 5/7 of this 140 right here be prefer cones. So 5/7 times 140 is going to be 100. So I should have 100 children prefer cones and only 40 prefer cups, because that's 5/7 right here and 2/7 right here. Does that make sense? And I know this because there's no association. They are all independent. Now I can do some math. There's 150 total. This should be 50 and 20. That's just subtracting based on what I know about these numbers adding up. And so now I can see 5/7 of the data is adults preferring cones. 2/7 is adults preferring cups for that conditional distribution. So that is the correct chart. That's what it should look like. And now what I can see is that no matter if you're an adult or a child, you have the same conditional distribution for your preference. And that means that they are independent. There's no association. And what is that, C? Am I seeing that right? Yeah. So your correct answer is that. There's not a question like that on the test, but hopefully as we walk through it, that was making sense. This presentation is available online, like always. So if you want to go back and recreate this table on your own, make sure you understand it, then I encourage you to do that. Okay, the only thing to mention on this one, this is showing kind of it's segmented bar charts based on return versus didn't return. Keep in mind with categorical data, there's no natural order for how we present it. We could have easily put the psychology bar chart up at the top and moved in class down. We could have moved it all, switched it around in all these different ways, which means we can't talk about any positive or negative associations. And we'll talk about positive and negative correlations later, which have direction, but because there's no natural way that we show this, obviously it looks like there's some kind of negative trend, but that's just because of how we chose to present it, not because of some natural order to the way it should be done, if that distinction makes sense. So you can read, I just wanted to make sure that was clear. So if you read this, there's no such thing as positive and negative association in this kind of data because it's categorical. Okay? So we can talk about positive and negative trends when we talk about quantitative data. All right, I didn't want to talk about the full problem there. This one, it is a histogram. They're not asking you just to describe it. They're asking for you to do some more examination of it. So first choice, minimum price is $250,000. What we have is a bin of data that goes from $250,000 to $500,000. Potentially the lowest value home was $250,000, but it could have been $275,000, So which of these must be true? Well, it's not A. The maximum price is 2.5 million. It could be, well, technically it couldn't. It'd have to be just below 2.5 million. But let's say that it could be close to that, but we don't know that that's true. Bottom line, it's not the correct answer. The median price is not greater than 750,000. Let's come back to that one, because the next one here. The mean price is between 500,000 and 750,000. And I feel like this is one we could eliminate because you can see it's got a right skew. So that's going to pull our mean somewhere, I don't know where, but it's going to pull it somewhere. And I think it's safe to say it's not going to stay in this bin right here. So I'm going to go ahead and eliminate that as a possibility. The upper quartile of the price is greater than 1.5 million. So here's how we can deal with these two problems. It gives us numbers at the top of these columns. And we know that there's 304 homes that were recently sold. So knowing this information, here's what we can do. We can say, where is the median? There's 304 homes. Well, 304 divided by 2 is going to be 152. So the 152nd home price, when I line them up from smallest to biggest, that's going to be between that and my 153rd. That's going to be where the median is. So I just need to find where that 152nd home is from smallest to largest. I don't have it all laid out in a line, but I do know here's the 38 lowest. Here's the next 120 lowest. So if I add that up, 120 plus 138 is 158. Well, looky there. I know that this median right here has to be found in this column. If that logic makes sense. So I don't know the exact price, but I know it's not going to be greater than 750,000. There's my correct answer. If I was looking for the upper quartile, then I could split this into fourths and I could figure out where that quartile is going to be and count from the top down. We'll have another example in a little bit where we'll see something like that. Okay, but hopefully that logic is clear. If there are any questions, I'm still checking to see if there's like hands raised or anything like that. So feel free to ask questions as we go through, but I am trying to make up for lost time. Okay, now a graph not shown, intentionally not shown, of the selling prices of homes in a certain city for the month of April reveals that the distribution is skewed left. Just let me check something real quick. Okay, is skewed to the left. Which of the following statements is the most reasonable conclusion about the selling prices based on the graph? This one is going to be tricky because it's a very conceptual question, but I'm going to start off with a negatively skewed distribution. Now in this, I would have a mode about right here. My median should be a little bit to the left of that. So I'll just mark this as the median. And my mean, if we remember, that's not resistant to outliers. So the mean is going to be dragged even further. So we're going to start with this. So let's kind of see which one makes sense. The mean is greater than the median. Well, we can already see based on our drawing, no, that's not going to be true. The median is the average of the first and the third quartile. I would say that this is never a good answer. That's not how we find the median. In a perfectly symmetric unimodal distribution, that could very well be true, but that would be by accident. That's not a good answer. There are fewer selling prices between the first quartile and the median than there are between the median and the third quartile. Here we need to think about vocabulary. I'm going to draw a box plot for this data now. It's going to be skewed left. I'm going to have a box and then a smaller right tail. And my median is probably going to be somewhere over there. We have to remember that when we're talking about a box plot, every single part of it contains 25% of the data. So when we look at this question or the answer choice, there are fewer selling prices. The selling prices are points. There are fewer points between the first quartile and the median than there are between the median and the third quartile. Think about the words there. It has to be the same amount because between the first and the median, you're going to have 25% of the data. Between the median and the third, there's going to be 25% of the data. It's the same number of data points. So that's not our answer. There are more selling prices that are less than the mean than selling prices that are greater than the mean. So we're saying there's more data to the left of the mean than to the right. Well, we know that there's an equal amount of data to the left and right of the median. That's right where 50% of the data is. So the mean being to the left, let's just say the mean is right here. I don't know. That means that less than 50% of the data is going to be to the left of the mean, and more than 50% of the data is going to be to the right of the mean. So hopefully that logic is clear enough for you. So this one can't be true. That means there should be more data points to the right, not greater than, not less than the mean. Okay, so that leaves, if you feel confident in your logic thus far, you know what the correct answer is. It's E. But let's explain what this is talking about. The value of the maximum minus the third quartile is less than the value of the first quartile minus the minimum. We're talking about the values here. So whatever that highest number is minus Q3. So Q3, remember, is just either a data point or an interpolated point, but it's some data point that defines where the 75th percentile or 25th percentile is. If I subtract those two, I'm going to get some kind of a difference between them. So I'll just put the change, delta, delta x. If I do the same thing down here, I'll put delta x sub 1. If I take the first quartile and subtract the minimum, knowing it's left skewed, this change in x is going to be much bigger. Okay? So I just want to make sure it's clear. This difference right here is much bigger than this difference right here. So if you read that, that's what that's saying in E. The value of the maximum minus the third is less than the value of the first minus the minimum. Yes, that's true. It's kind of a mind bender to read these questions and try and work through what they're actually saying. But you get better at this with practice. Okay, you're not going to be like super fast at this the first time, but you get more and more comfortable with these concepts and you get better. Question 10, really quick on this one. I just wanted to show this one. Don't overthink problems, because I know this is one I would overthink. When I look at this, I see it's bimodal. And then I see that there's other data down here. So if I look at my answer choices, my first inclination is bimodal with a gap, because it seems right. And that's the answer. All right, don't overthink it. And you might not have overthought this one, but I know that I maybe have a tendency to look at it and be like, do they really mean that's a gap, or is that maybe something else in their mind? So that is the correct answer. Okay, this one, okay, dealing with two-way tables on this, no, it's not a two-way table, I'm sorry. This is a summary of two data sets. We have 5 number summaries for age group 20 to 30 and 5 number summaries for 40 to 50. Okay, so I'm going to read this. I want to make sure we're all on the same page at the beginning. Resting heart rates were recorded for 2 samples of people. One was between 20 and 30, the other sample between 40 and 50. Here are the 5 number summaries. The values 60, 62, and 84 were common to both samples. The 3 values are identified as outliers with respect to age group 20 to 30 years because they are either 1.5 times the interquartile range, greater than the upper quartile or less than the lower quartile. That's our standard definition of outliers that we're familiar with. Using the same method, which of those 3 values would be an outlier for the other group, 40 to 50 years? So what we need to do is figure out where the fences are for our 40 to 50 group. That's really all it's asking us to do. So the first quartile is 70, the upper quartile is 76. So the IQR is just going to be 76 minus 70, which is 6. When I do 1.5 times that, you can probably do that in your head or quickly on the calculator. You know that your fences are going to be set 9 above the third quartile and 9 below the first quartile. So to figure out where that is, I'm going to add 9 right here, which tells me that my upper fence is going to be at 85. My lower fence is going to be minus 9 right here, which puts it at 61. So any value lower than 61 is an outlier. Any value greater than 85 is an outlier. The only points I'm interested in are these 3, 60, 62, and 84. Which of those is an outlier? Well, the only one that falls outside of the fence is 60. So there it is. Okay, so I will move on from there. All right, a graduate student conducted a study of field mice in rural Kansas. The student obtained a sample of 100 field mice and recorded the weight in grams of each mouse. After the measurements were taken, it was discovered that the scale was not calibrated correctly. The student adjusted the 100 recorded measurements by subtracting 3 grams from each measurement. Which of the following statistics for the weight in grams of the field mice was the same value before and after the adjustment? So just to make sure this is really clear, you take your data, you have x sub 1, x sub 2, x sub 3, what, and it's weight here. And now the correction that's being made is that we're going to subtract 3 from each of them. So the median is one of these points. And we don't, or it's, in this case, it's going to be interpolated between two of them, the average of 2 points. So it's going to be changed by 3. The mean is going to be all those values added up divided by the number. All those have that minus 3. So the mean, sorry, that's not the correct answer. Oh, I didn't mean to do that. Okay. The mean is also going to change by 3. The first quartile is one of these points or an average of 2 points. And so that's going to have changed by 3 also. Same logic with the third quartile. The only thing that doesn't change is the interquartile range, because the interquartile range is just your Q3 minus your Q1. So if those both shift by 3, then that doesn't change the actual range. So that's the only thing that doesn't move. All right, just about 4 or 5 more multiple choice, and then we'll talk about some FRQs. This is one in particular. It's challenging. I just wanted to talk about it so you can get better conceptual understanding. There is not a question like this on the test. Okay. So this is data from the Lewis and Clark expedition. I believe Lewis and Clark, but, well, it just says land surveyors, not Lewis and Clark themselves. But in the Louisiana Purchase, they were, their task was to note the size of trees. And these are bur oaks. And the question is, an outlier may be defined as a data point. Okay, we know the definition of outlier. The question really is, according to this definition, what is the diameter in inches of the smallest tree that is an outlier? And at the beginning of this, it seems like there's no way to determine this. There is, obviously, it wouldn't be a question otherwise. So keep in mind that we have this table right here, or this column, the cumulative relative frequency. And one thing we need to remember is that the Q1 is just the 25th percentile point. The median is the 50th percentile. And the Q3 is the 75th percentile point. So this is showing for each one of these groups, what percent is being added to the total? And the 25th percentile point, well, let's start with the median. I know it's not asking for median, but the median is going to be wherever that 50th percentile point is. And I can see right here that 48.3% of the data has been accounted for, which means as I add another point, that's going to add more to the data. But the 50th percentile point is going to fall in this group right here. So the 50th percentile, the median, is going to be 14 inches in diameter. So by this logic, we can do the same thing for the 25th percentile point and the 75th percentile point. 19.5 is right there. 31.8 is right there. Somewhere in this collection of data is a 25th percentile point. My Q1 is going to be 10. I'll show that the median is 14, but we're not asked for it. Now I need to find where the 75th percentile data is. Here's 73%. There's 84. So in this pile of data, one of those is the 75th percentile point, and then it's 18. So from there, we can figure out the IQR is going to be 8. The fence for the outliers is going to be set 12, 1.5 times 8. So 12 from the upper quartile. So it looks like when I add 12 to that, it's going to make it 30. Now, 12 subtracted from 10 is negative. That doesn't make any sense. So we're only going to have upper outliers. So there's not a question like this in the test, like I said, but I think it's worth it to understand conceptually how you'd approach this. Okay. And as I'm going really fast through this, you're not necessarily having time to read everything and wrap your head around it fully. I get that. So I encourage you, if there's one question in particular that you're struggling with, you can either hang out afterwards and we'll go back and break it down a little faster, or watch this video again so that you can pause it and you can just kind of read the question, try and work through it on your own. Make sure you get it. This one, we had a question similar to this before, but it's asking for the interquartile range of this distribution. You're not just going to look at it and pick out the interquartile range. What you need to, first of all, do is recognize that it tells us the total. If you didn't have the total, you'd have to count up all these columns. That would be time consuming. But knowing there's 100 adult men, then the 25th percentile is going to be that 25th man. So I just want to count from the bottom, count up until I find where that 25th man is going to be. So I 1, 2, 3, 4, 5, 6, 9, 13, 18, 24, which means right here, that 25th percentile man is going to fall in that bin, 66. So Q1 is 66. I can do the same thing, but counting down from the top to find Q3. It's going to be the 75th percentile, so I want to count down 25. And technically, it would be between the 25th and 26th. We'd average that, but we don't need to worry about it. Okay, so 1, 2, 4, 6, 9, 14, 20. Okay, so I know it's going to fall on that right there. So Q3 is 71. Interquartile range, now it's easy. It's 5. Okay, so we good with that logic? All right, let's move ahead. All right, so this is a two-way table, and it's consideration of whether was color a consideration when you were buying the car, and what was one feature that was really important to you? So that's going to be these right here. This type of question, I wanted to talk about it because it's very tricky. It's the wording of the question that will determine how you answer it. And I'm going to give you two possibilities here. And this is such a tricky question. These are, in my mind, one of the trickiest types of questions. Which of the following is closest to the proportion of people who responded no to color consideration and who identified safety as the additional feature that was most important? So the question is, are we looking for a conditional distribution and therefore probability, or are we looking at an overall out of the total? And the key word right here that sticks out to me is and, okay? And I'll show you kind of how I think through this. What is the closest to the proportion of people who have two characteristics that match? One was that they responded no to color consideration, and they identified safety as an important feature. So there's 192 of those. And that's going to be true no matter how we interpret this problem. So we got 192. So the fact that we're kind of looking for an intersection of those two characteristics, what's the proportion of those people out of what? I interpret this as out of the total. Okay. So that it would be 192 out of 1,092, which I believe would give us A as the answer. Okay. Now the word and, I want to consider this problem again, and I just want to eliminate the word and. In fact, let's see if I can do that in a way that, no, I'm not even going to try. Okay, I thought I could do it quickly, but I'll just cross it out. Okay. Which of the following is closest to the proportion of people who responded no to color consideration who identified safety as an additional feature that was important? Here is where, when I read it, it reads more like a conditional distribution. okay? Because now they're saying, out of the people who responded no to color consideration, so out of this grouping, which of them identified safety as an additional feature? So 192 out of 534. It's a very subtle and tricky thing, but you have to consider, is there a condition? Is it a conditional distribution they're looking at? What is the proportion of people who identified safety as an additional feature on the condition that they responded no to color consideration? You know, it's, you know, the reading there can be very hard, but that's how I'd interpret it. The fact that it said the and, so I'll get rid of everything, means we're looking at the people who intersected right here out of the total. Okay. So let's, I know that one's a little confusing, but, or at least it seems that way to me. Maybe you guys are sitting there like, okay, yeah, it's obvious. I totally knew that. So this one right here, I only wanted to look at because it's important to know something about standard deviation. And so the statement here is which one must be true. It's underlined. You really need to notice that. All of these, well, no, not all of them. Most of these could be true, but one of them must absolutely be true. The mean of data set A is equal to the mean of data set B. It very well could be, but these are bins of data and we don't know the exact data points. So I would say, please stop annotating on the page. I would say that doesn't have to be true. All right, the median of data set A is equal to the median of data set B. Again, could very well be true, doesn't have to be. The range of data set A is equal to the range of data set B. Could very well be true, doesn't have to be, because we don't know if the highest value here is 60, 58, 59, 51, 50, you know, so there's all kinds of values it could be. Okay, so that leads to these two. And I mentioned I want to talk about standard deviation here. Standard deviation is the average distance away from the mean. So notice that right here on the left, the mean is going to be here, right in the middle. And a lot of the data is really far away, so the average distance away is going to be pulled further out. On the right, the mean is right here. Most of the data is clustered in the middle, so the average data is actually, that might be our standard deviation, pretty close to it right there. So what is absolutely true is that the standard deviation of set A has to be bigger than the standard deviation of set B. So your answer here is E. That absolutely has to be true. And we're going to talk, that's okay. I just saw the note. I understand that can happen accidentally. So it is something we're going to talk about more when we get to the next unit. It's really just chapter 6, but good to talk about it here. Last multiple choice question. Okay. So on this one, we have the figure above summarizes the heights. Oh yeah, and this one, I'm not actually going to go through it. I want you guys to read this question. I want you to look at it and come up with your answer in your head. And in about 30 seconds, I'm going to circle what I think is the correct answer. All right, hopefully you guys have all had time to identify your preferred answer. Here, I do want to let you guys annotate. It's stepping out on a limb, being brave. Feel free to circle the answer you think is correct. Okay. Once we have a few answers, we kind of hover around D, and yeah, that is the correct answer. It's just interpreting these. Remember the IQR, the key thing here is IQR is however wide that box is. Median is that middle line. So you can just compare those two things. There could be questions where it asks you to think of other parts of the plots, but really that's all you're looking at with this one. So good job, even if you got it wrong, good job, because you know, it's, what am I doing here? It's good to kind of read through and just kind of think through it. I know I'm doing a lot of the thinking for you right now, just for time, but yeah, I think that's good. I don't know what else to say about it. There it is. Now we're going to look at some FRQs. Okay, and the key thing with FRQs is write out everything. I revert into cursive, that's the way I write usually, and include the context. So every FRQ answer is going to be a sentence or a paragraph, with maybe some exceptions, but I can't even think of them. I'm just allowing that there could be an exception to that. So generally, it's writing something out. Okay, so the very first part, well, let's read the prompt. A university researcher is interested in comparing the percents of high school seniors who took a college entrance exam for two different regions of the country, Region 1 and Region 2. The researcher recorded the percent of seniors taking the exam for each high school within the two regions. The box plots of the distribution of the percents of the box plot of the distribution of the percents of seniors who took the college entrance exam are shown below. Okay. So Region 1 and Region 2, compare the distribution of percent of seniors who took the college entrance exam for the two regions. Okay, so we want to compare. When we compare, we're using things like greater than, less than. And there's some things we can compare, like the center. Remember DISCO, first of all. So we can compare the centers, and in here we know where the median is. I would guess that's about 8 or 9. I'll call it 9. The median here, I skewed my line a little bit. I would say we can just say 73. You're not going to be counted off if you thought it was 73 and it's actually 72. Okay, so I want to compare these two. I could say and this is where the median this is where you want to include the context. The median of percent of high school seniors who took the college entrance exam, college entrance exam for Region 1, and I'll just put what I'll say it's about 73%, is significantly greater than the percent of seniors who did the same. You might even want to, just for, CYA, cover your butt, you might want to just write it all out again. The percent, I'm not going to do that right now. Percent of seniors who took the college entrance exam for ... for Region 2. That would be about 9%. You just made a comparison between the centers. You can also compare the spread, the interquartile range. I'm not sure I want to write all it out, but if you follow the same sort of model right here, I'll just change some words out. The IQR of percent of high school seniors who took the college entrance exam for region 1, the IQR here would be from about there to there. Let's say it's about 9. Okay, just quick guessing. So 9 is significantly greater than the percent of seniors who did the same for region 1. And this one, I'd guess, is maybe about 4. If you take this upper quartile and subtract the lower quartile, it seems like the difference is about 4. Okay, so there you are. You just described the centers and the spreads, compared them to each other, used greater than, less than. And you might not say significantly greater, but for the second part, but hopefully just understanding how to write out an answer is making sense. In writing a report, the researcher produced a single histogram of the combined data for region 1 and region 2. Describe the shape of the histogram. Well, this is where, if we took all this data and just mashed it down, if I drew a distribution of this data set right here, it looks like it's going to be normally distributed about right there. This one's going to be distributed about right there. I don't know if it's normally distributed. We'll talk about that more. And there's going to be a little bit of an outlier right there. So that's what I'm going to think. I've got a hump of data right here, this little outlier, and then another hump of data. So now I just need to describe that. It's bimodal, that's for sure. This is DISCO. I'm not going to write this out. But the distribution of all seniors who, the percent of all seniors who took the college entrance exam for regions 1 and 2 is bimodal. It is, if I describe the spread, actually I wouldn't want to describe the spread except to say that it goes from a range from about 4% maybe up to a max of 85% maybe. So I could talk about the range. The center, we don't know. There's a lot of factors that could determine where the center is, but the center might be somewhere between 40 and 50. I think it's fair to assume that that might be where it's at. So you could say something to that effect. The outliers, there's one outlier or a gap. You could talk about the gap / outlier. It's right here. So it's just going through and describing a distribution. So if you guys are feeling good enough with that, understanding how to run through that DISCO for a kind of procedure, then you're good to go with that. Okay, and I will call that good. Again, any questions of any of these problems that we've talked about, we can go back and look at in a minute, but let's get through this last FRQ. And this one right here, we've got a stem plot or stem and leaf plot. 34 college students were asked how much money they spent on textbooks for the current semester. The responses were shown in the following stem plot. It's important to read the key because when I first looked at this, I was like, $12. Oh, it's 120. Even that's really low. You probably know books cost way more than that these days, but they just got rid of the 0 at the end. So that's how they decided to set this up. So describe a procedure for identifying potential outliers and use the procedure to decide whether there are outliers among the responses for the money spent on textbooks. You do need to do just that. The explanation, you could describe how you're going to split the data up into quartiles. I begin by dividing the data in half and dividing that data in half again, dividing that data in half again so that I can find the median and the first quartile and the third quartile From there, I find the interquartile range by subtracting Q1 from Q3. And I'm saying out loud what I would be writing. I would then multiply that times 1.5 and find any values that exceed that distance away from the third quartile, lower than that, or higher in the from the third quartile. So you describe the process. If you know the process, it's just a laborious process of typing it all out or writing it all out by hand. If you don't, then you're gonna be caught. You're gonna know that, oh, I don't know how to find outliers. I just let my calculator do it. And that's the purpose of this question. You need to know how it's done. So once you've done that, you can actually determine if any of these are outliers. This one could be. A question that came up in my earlier class today, this 7 right here, you'll notice that there's no data points. Apparently no one had to spend anywhere in the 700s for books. But you still need to include the 7 there to show that there were no data points. That lets us see the distribution of the data and lets us see that there's a gap right there. So if you were creating one, don't just skip the 7 because they're like, oh, there's no 7, so I'll just jump down to 8. Hopefully pretty obvious. The last part of this one, based on the STEM plot, write a few sentences describing the distribution of money spent on textbooks for the 34 students. Okay, this I don't need to say any more about. You can convert this probably in your head or on paper to a distribution. Notice that the lowest value is here, the highest value is at the bottom. So it's gonna be something like this with, of course, your outlier. So you can describe that distribution. We just spent some time talking about it, so I'm not gonna do any more of that here. Disco, there. With that, here's your homework. Complete the FRQs. It's not gonna be turned in, but if you have your answer right there on paper, you will, when you take the test, you're gonna see one of those two, and you're just gonna be able to copy everything over, okay? If you don't do it ahead of time, you'll have to figure it out on Monday. Monday is the unit test. The way this works is if you want to spend class time getting some extra help on Monday, that's fine. I'm just gonna be hanging around answering questions. If you're ready to take the test, you will take the test right then and there. If you hang out in class and you don't do the test right there, you'll need to take it that evening, and you'll just have to get it done that night. If you decide if you forget to take it that evening, you know, you need to take it that day. That's all. Okay. Any questions? And real quick, if you're about to ask, sorry to interrupt, but if you are feeling good, it's 2:10. I did okay based on when we started the class. I tried to get it done in an hour. That's about right. Have a great weekend. Study, but also relax. It's been a long week. And I will see you on Monday. I'm going to now hang out for anyone who wants to get help. Otherwise, you can log off and enjoy your weekend.